छ। यस ओपनिङ सेरेमनीको प्रमुख अतिथिको आतिथ्य ग्रहण गरिदिनु हुन म नेपाल दूरसञ्चार प्राधिकरणका अध्यक्षज्यू श्री दिगम्बर झाज्यूलाई आग्रह गर्न चाहन्छु। साथै आसन ग्रहण गरिदिनु हुन प्रमुख अतिथिज्यूलाई आग्रह गर्न चाहन्छु। Also, I would like to request President of npNOG, Mr. Samit Jana, to take a seat. I would also like to request Mr. Rajesh Charia, President ISP Association of India, to take a seat up front, please. Next, I would like to request our keynote speaker, Mr. Sailesh Gupta, Vice President Tata Communications, and Mr. Mohit Saxena, Principal Architect Cisco System, to come up front and take a seat, please. I would also like to request Mr. Pubudu Jayasinghe from APNIC to come front and take a seat, please. सर्वप्रथम म प्रमुख अतिथिज्यूलाई पानेसमा बत्ती बाली औपचारिक रूपमा यस npNOG 4 को सुरुवात गरिदिनु हुन अनुरोध गर्दछु। धन्यवाद प्रमुख अतिथिज्यू। यस npNOG 4 को उपस्थित सम्पूर्ण महानुभावहरूलाई स्वागत गर्दै म अब यस npNOG 4 को स्वागत मन्तव्य व्यक्त गर्न हुन npNOG का अध्यक्ष श्री समित जनालाई आग्रह गर्न चाहन्छु। वेलकम पहिला वेलकम ल ठीक छ। स्वागत मन्तव्यको लागि एकछिनपछि गर्ने भन्ने उहाँको रिक्वेस्ट अनुसार। सो फर्स्ट आई वुड लाइक टु रिक्वेस्ट मिस्टर मोहित सक्सेना, प्रिन्सिपल आर्किटेक्ट सिस्को सिस्टम, टु प्रेजेन्ट अ टपिक अन सेगमेन्ट राउटिङ बेस्ड प्रोग्रामेबल नेटवर्क, अ केस स्टडी। मोहित।
So, hello, gentlemen. My name is Mohit Saxena. I work for Cisco Systems. I'm one of the principal architects based out of India, and I've been involved in various orchestration, automation projects, transformational projects where we have transformed the telco networks and how they look like. This is a brief introduction about myself. And this is the abstract of today's session. So in today's session, my objective is to give you an understanding on what segment routing is and how the IP networks are evolving and how the transport networks are evolving and becoming more programmable, and how the operational excellence is being adopted by various operators in the transport networks. So before we go to the topic, I would just take you through the current deployment landscape. So most of us here are from various operators, and we know these challenges and this operator paradigm, which is like the operator networks are decades old. So they have evolved over decades with different technologies, and it's like there are various islands in the network which is formed now because they're multi-vendor, various islands doing various functionalities, and that is adding to the complexity. And also there is a big challenge that now, since the operators have accumulated a lot of inventory from various vendors, then that inventory cannot be just write off immediately. So you're sitting on a lot of inventory, which you want to sweat the assets also. So this is how the networks used to be earlier. It was native L2 from the cell site routers to your access or to aggregation. And the protocols which were used were like STP and REP kind of protocols, which are mainly L2 switching protocols. Then we moved to IP MPLS networks where we started bringing L3 till the edge. But then the problems of route scale and the ASIC scale started coming in. So we started evolving the MPLS network to unified MPLS, where we started doing BGP labeled unicast based route distribution using RFC 3107. So these are the networks till now. Most of the operators in the region are using unified MPLS or seamless MPLS, as we call. So unified MPLS could be a vendor specific term, but seamless MPLS is like more of an industry term, where the access, the aggregation, and the core of the network are stitched in an LSP using BGP. So before, the traditional networks used to have just one data center at the core, and there used to be metro and access. And now, with the invent of NFV and with the invent of mobile edge computing, the central office and distributed offices have started evolving, and the metro specifically has started evolving into a more, I would say, functional network. So if I give a brief of segment routing, what it brings us, what the value it brings us. So it's like simple, scale, and seamless. So simplicity means now we are reducing the protocol stack, because the protocols which are running in the network are like IGP, then you have got LDP, then you've got BGP. You also have got RSVP tunnels for your fast protection and all. So we are using the protocol stack to just 3 protocols, which is just the IGP and BGP and your SR. So those are the 3 protocols which will suffice for all your network needs. Then scale is something which segment routing brings in from default. Reason being, there are lesser protocols and there's no states in the network to be maintained. So with the less compute in your ASIC, you can do more work. So of course, you can fulfill more scale needs. Then seamless is because you can still have segment routing coexist with your existing LDP. So you have LDP running in your network with the traditional MPLS. You can evolve it to segment routing without much of challenges. So there is a huge industry backup for SR because there are a lot of customers which have already started adopting it. So be it web scale players, be it operators, be it enterprise, then we've got a lot of support from IETF. So it's an IETF standard now. So it's nothing proprietary or specific to a vendor. All the vendors have come to a common platform where all the vendors are supporting segment routing. And there is an interop organization also being built up where the interop testing between various vendors is happening to support seamless segment routing across the vendor ecosystem. So the value proposition is like you've got an IP MPLS architecture designed with SDN in mind. So when we talk about SDN, software defined network, we might think means there are various ways to define SDN. So one way would be that software will do something for me which my network is doing as of today. Or there could be another way of defining SDN would be the intelligence of my network will be separated to software and compute, and the throughput or the forwarding plane will still remain on the custom ASIC. So the way we want to define it, we can define SDN, but before we do SDN, segment routing is the first thing which you have to enable to make your network programmable. So if I want to give an example of a segment routing based approach, it's like when you travel in an airline, suppose you're traveling from Kathmandu to Moscow and maybe via New Delhi, suppose. So when you go to the check-in counter, they put a baggage tag on your bag. And that tag already has all your transit routes where your bag will go and the final destination. So it's like the routing is defined at the source. So till now, when we talk about routing, it's mainly a destination-based approach because there is a special way of doing source-based routing as of today. I think most of the network engineers would know this. That is PBR, policy-based routing. And as soon as we hear PBR, most of the network engineer will say, no, it has a lot of resource consuming stuff and we should try to avoid it. But with segment routing, we are actually doing a source-based routing, not like PBR, but we are defining the path of the packet right from the source. So that is the way forward for application engineered routing. So if I call it application engineered routing, I mean that if I'm running like tens and hundreds of applications in my data center, my application can decide what is its requirements. So if I'm running a voice application with a requirement of 10 millisecond latency, the application can dictate that to the network that, look, I'm looking for a 10 millisecond latency path from point A to point B, give me that path. And the network controllers can give the SR stack, the segment stack to the head end so that the path is determined right from the source that the application will take. So if I have to define the SR value proposition into three tenets, so optimized capex, which is because of the stateless network. So you're not maintaining the states of tunnels on every node. It's only the head end which maintains the state. So you save a lot of capex there. Then automated 50 millisecond protection, which is with the TI-LFA. So TI-LFA comes along with your segment routing. So once you have deployed segment routing, the way to have fast convergence is not FRR anymore. It is a version, or I would say it's a topology independent loop-free alternative so that you avoid all the micro loops and you always have a guaranteed 50 millisecond or below 50 millisecond protection. So you reduce OpEx there. And of course, it brings the programmability with protocols like BGP-LS and PCEP. Both are IETF standards as of now. So with those protocols, you can have the controllers dictating how to give a path to an application on your network and how to optimize your link utilizations within your network. And that will give easier monetization and an excellent customer experience. So this is a comparison of segment routing based network with a normal MPLS, IP MPLS network with LDP. So on the left hand side, you can see what you want to achieve, and how it is achieved is shown on the right hand side. So if you talk about MPLS signaling protocol, so in segment routing, it's only the IGP. There is no LDP there. So there is an extension of IGP which is used to propagate your labels within the network, and the labels here in segment routing are called segments. Then you've got 50 millisecond latency, IGP LDP synchronization. Most of the transport engineers would know that this used to be a major problem to manage. So now if it's segment routing, you don't have to manage that. Then extra TE states, you don't have to manage the extra TE states. Optimum backup paths are available on demand. Next hops are available. ECMP capability for TE, which is one of the major factors. So I can give an example here. So if you are running an MPLS TE, an explicit path TE from point A to point B in your network, and there are some ECMP equal cost multiple paths in your network, your TE will take only one path. Maybe you are running 3 paths with 10 gigabit link each. So technically you've got like 30 Gbps of capacity lying for that path, but your TE will traverse only through one path. So that will choke that path. But in SR, it's not the case. With SRTE, the SRTE will take the IGP and will also consider your equal cost multiple paths. So these are some of the use cases and the value propositions for SR, like the traffic engineering stuff which we talked about. On-demand next hop is another good use case with SR. So like you have got different segments in the network, like access, aggregation, core, and you have to do some route leaking, or you have to do BGP RFC 3107 labeled unicast in order for LSPs to stitch between each other and form a service. But that is not a requirement anymore with SR. In SR, you can have different network segments, still stay different, but you can have a controller get the link states from all the segments and give you the next hop on demand. So if you've got like 5 segments in the network, 5 islands in the network, which are not talking to each other, but talking to a single controller, then if you have to make a service from island A to island D, the next hops and the NNIs will be determined by the controller. You need not to have those route leakings and BGP LUs within the network. So that is one of the good use cases with SR. And of course, the failure protection we talked about, it's topology independent, and each network island can have its own network protection. And this is the protocol stack I was talking about. So as of today, this is the protocol stack running in your network. It's IP, IGP, MPLS, LDP, RSVP, TE, BGP, LU, TLDP, BGP. And with SR, you are compressing it only to 3 protocols: IP, IGP, SR fabric, and BGP for your services. That's it. So industry ecosystem, I can give some public references for SR. Google, Facebook, Microsoft, Yadex, Apple, Amazon, they have all embraced SR. And it's multi-vendor. So Cisco, Alcatel, Juniper, they're all cooperating on IETF standardization. Even the Linux kernel has adopted the SR. So as of today, if you have Red Hat system running in your data center, even that system can give an SR label on the packet. So the SR is proliferating till the data center. So you will have, in near future, you will have a unified seamless fabric, be it your transport network, be it your data center network. You can go anywhere to anywhere. And this is the RFC if people are interested. So it's 7855 standardized in 2016. That is the first SR RFC. And there is a working group called Spring. You can Google it, Spring Working Group. And over 25 drafts are maintained by the SR team, and almost 75 to 80% are the work of Cisco. So this is an interesting topic. I'm sure you would like it. This is the technology overview, how it works. So what SR works upon is segments. And what's a segment? A segment is a small instruction. It could be a label, or it could be an instruction like go to node C or go to node D. So suppose this is the network and we have a packet starting from node 1. So node 1, we are taking node 1 as the head end, and the end destination for the packet is node 5. So what I do is, at node 1 itself, I'm giving a set of instructions, putting it on the packet. So the set of instructions is go to 2, 3, 4, 5. So I have already defined the path for this packet right from the head end, and the packet will traverse like this. So there are two forwarding planes for SR. One is the MPLS forwarding plane, which uses the normal push, pop, and swap operations as you do in LDP MPLS. And there is another forwarding plane for SRv6, which uses the routing field in IPv6 header. So there are developments happening on SRv6, and SRv4 is something, SRMPLS is something which is available as of today and is being deployed at various places. So we talk about two basic building blocks. So one is so now I'm talking about the segment IDs. So the segment IDs are of two types. One is the one distributed by the IGP, and another one is the one distributed by BGP. So the two types of segment IDs distributed by the IGP are the prefix segments or the prefix SID and the adjacency SID. And for the BGP, it's the prefix segment or the peer segment. So this is IGP prefix segment. So here, if you have node 5 as the end destination, so you can define a prefix SID for node 5. You can define it as the label plus the index. So if you say the label is 16,000, and if you do the index for the node as the node number, so the SID becomes 16,005. So now any router from the left-hand side, if it wants to reach router 5, you just have to put this prefix SID 16005. It will reach to 5 using the IGP. So there is no tunnel. It will use the normal IGP metric to reach router number 5. So there are two equal cost multipaths here I have shown. Here, 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 here. So traffic is going to load balance between all these paths to reach node 5. So here you can see that from node 1 to node 4, if I have put the prefix SID as 16,004 for node 4, I'm using both the equal cost multiple paths to reach node 4. Now, there is one small twist to the segment ID. So we talked about the segment ID, which is global in nature, which is distributed by the IGP. Now we are talking about something called the adjacency SID. This is also distributed by the IGP, but this is more specific and localized to the box. So if I give a segment ID for 16,004 to reach router 4, the packet will reach router 4, but now there are two paths from here. I can define which path to take. If I have to do an explicit tunnel, that if there are 4 or 5 exit paths for my packet, I can define which specific exit path my packet should take. And that's what is done and achieved by the adjacency SID. So I have got two exit paths here. I have got two adjacency sets, 24,042 and 24,045. So now if I do the packet and give this segment list to the packet, which is 16,004 and 24045, then this is the path my packet will take. From node 1 to node 4, it will take your normal IGP path, which is equal cost or whatever, however your IGP is converging. If there is any breakage in the link, it will take the other, I would say, converged path. And when it reaches router 4, then there are two ways to reach 5, but it will only take this one because we have statically defined an explicit path. So now I'll talk about BGP segment set. So just like SID, this is the prefix set for BGP. So when you distribute the prefixes using BGP, and if you have to give a segment ID for them, then you can use the BGP prefix set. And there is a peering segment ID for BGP, which is used in BGP LS protocol, where you collect all the link state and give to a controller. So I'll quickly go with the migration case study. So migration to SR from normal MPLS is like very easy. You start making your network SR ready without actually converting your forwarding plane to SR. So you just put the SR configurations, let LDP remain. It can coexist with LDP without any issues. And then you start making nodes one by one SR prefer. So SR prefer means it will start preferring the SR label stack on LDP. And that's how your network's gonna become SR, and then later on you can remove LDP. So initial state is all nodes are running LDP, not SR. All nodes are upgraded to SR. Then all Ps are configured to prefer SR label imposition, and LDP is removed from the network. Final state is all nodes run SR, not LDP. So these are some of the considerations from the case studies which we have done and the deployments which we have done in Asia Pacific region. That sRGB size and SR domain boundaries is very important. It depends on how big the network is. You have to plan the sRGB very carefully. And also you also have to take care that the sRGB which you plan does not overlap with your existing LDP label space. So this is from one of the operators, one of the big operators in Asia Pacific region. This is the sRGB from one of the big operators which we designed the SR network for. So this is the core which is running around 1000 ASR 9K nodes. This is the aggregation, around 400, 500 nodes per circle. And this is the access, which is like 150,000 nodes. And these are the sRGB ranges which we put for this network. So 6,000 sRGB sets were put for the core, which are like 1,000 nodes. Then 66,000 sets were kept for the circles, which is 11,000 nodes, and 150,000 sets were reserved for T5, which are 150,000 nodes. So interworking scenarios, this is like just two scenarios, LDP to SR interworking and vice versa. So if you are going from LDP to SR, it is not at all an issue. If half of the network is running LDP and the packet is traversing from the LDP network towards the SR, LDP will just do a normal swap operation and you will have the SR label, and that's it. After that, it will all be SR. However, when you traverse the opposite direction, which is SR to LDP, then the first node will not know what is the SID for me to go to the destination. And that's how you have to use a mapping server. So mapping server could be a functionality on the box itself, or it can be a functionality on a Linux server. So mapping server, what it does is it defines a SR SID, which is the segment ID for for a destination which is in the LDP island. And the migration strategies, outside in and inside out. So outside in, as the term suggests, you start deploying SR in the axis and in the edge, and then you deploy it in the core. And inside out is like first you deploy in the core, and then you migrate towards the axis. And of course, there are operational preferences on plus and minus for both the methodologies. If you start from the core, then the nodes are less, and you can deploy SR very quickly. But of course, the impact is also very huge. If there is any manual mistake or something, of course, it will impact your core. But at the same time, if you do outside in, then you have got a lot of access nodes, but the impact is limited. So last, the conclusion. So you have got simple routing extension to implement source routing, packet path determined by prepending the segments, and the data plane is agnostic. You can have MPLS or IPv6, so there is no need to change the ASIC or to change the programming in the ASIC. The normal routers can support, whichever is supporting MPLS can support SR. And of course, you get TILFA, which is like the protection, path protection, which is less than 50 millisecond, carrier grade stuff. And of course, the ODN and the better utilization of your resources with segment routing. So that is all I have. Any questions? Okay, please feel free to get in touch with me. I'm around for today, and also you can send me emails on my email ID, and I would be more than happy to respond. Thank you very much, guys.
Thank you, Mohit. That's a lot of information, Mohit. I hope a lot of people have already noted down a lot of things. He's talked about segment routing, and hopefully that they can take it up with during the course of workshop and further training programs that we will be organizing. Thank you again, Mohit. Next, म यस npNOG का अध्यक्ष श्री समित जानालाई यसको स्वागत मन्तव्य व्यक्त गरिदिनु हुन अनुरोध गर्दछु। समित।
Thank you, Rupesh. Thank you, everyone. सर्वप्रथम त नेपाल दूरसञ्चार प्राधिकरणका अध्यक्ष दिगम्बर ज्यूलाई चाहिँ स्वागत गर्दछु। यहाँ आएर चाहिँ हाम्रो कार्यक्रम इनअगरेसन गरिदिनु भएकोमा धेरै धेरै धन्यवाद। Similarly, all the guests, distinguished guests, all the speakers who has come from aboard, all the students, volunteers, and the sponsor who actually supported this event to make a huge success. So सबैलाई चाहिँ म एक्चुअली फेरि स्वागत गर्दछु। स्वागतको कार्यक्रम धेरै भइसकेको छ, so I just wanted to make it very quick and short. Basically, as Rupesh also mentioned in his opening welcome note, that running an event like this is not an easy job, right? So actually, it's take a huge effort for a volunteer like me, Rupesh, and all the other that we have. So basically, the छोटकरीमा भन्नुपर्दाखेरि हामीले चाहिँ किन npNOG गर्यौं भन्दाखेरि since last 5-10 years, actually, we have seen an exponential growth in our network नेपालमा पनि र ग्लोबली पनि हामीले देखिरहेका छौं। त्यसले चाहिँ धेरै कम्प्लेक्सिटिजहरु आइरहेको छ नेटवर्क अपरेसन गर्न, रन गर्न, मोनिटरिङ गर्न, प्लानिङ गर्नको लागि। अनि what we feel is, we lack a forum here where we discuss about operational challenges, the innovation that we did, the project that we work on. So, for example, just भर्खरै एकजना साथीले दिनुपर्ने नेटवर्क्सले सेक्युरिटी सेक्टरमा एक्चुअली त कति कुराहरु हामीलाई थाहा पनि थिएन होला कि नेपालमा चाहिँ यति धेरै वेबसाइट्सहरु भर्नेवाली थियो। उहाँले आएर यहाँ प्रेजेन्ट गर्नुभयो, नाउ वी आर अवेयर। सिमिलरली हामीले कपल अफ मन्थ चाहिँ वेबसाइटहरु ब्लकिङ गर्ने काम गर्यो। वी आर नट अवेयर दैट देयर इज अ राइज अफ VPN ट्राफिक also there. So यस्तो कुराको धेरै इन्फर्मेसनहरु चाहिँ जुन चाहिँ ब्याक एन्डमा चाहिँ हामीले गरिरहेको हुन्छ त्यो कुरालाई बाहिर निकाल्नलाई पनि यसले मद्दत गर्छ हैन। अर्को चाहिँ म सधैँ भन्छु नि हाम्रो नेटवर्किङ कम्युनिटी चाहिँ अलिकति साइ छ हैन। हामी चाहिँ ब्याक एन्डमा बसेर काम गर्छौं। सो उनीहरुलाई चाहिँ अगाडि ल्याउनलाई म चाहिँ उनीहरुलाई चाहिँ रोयल बेंगल टाइगर्स भन्छु के जो जंगलमा बस्न रुचाउँछ तर बाहिर निस्किन चाहदैन। सो आई वान्ट दोज रोयल बेंगल टाइगर्स टु कम आउट, राइट, एन्ड शेयर देयर एक्सपीरियन्स, नलेज एन्ड एक्सपोज देमसेल्व्स। द्याट्स द मेन मोटिभ। र npNOG को चाहिँ यो कन्फरेन्स बाहेक सबैभन्दा हाम्रो ठुलो चाहिँ फोकस चाहिँ बिसाइड दिस कन्फरेन्स इज अ वर्कसप है वर्कसपबाट चाहिँ वी ट्राई टु डेभलप अ स्किल म्यान पावर जुन चाहिँ हामी चाहिँ सजिलै चाहिँ नेटवर्क अपरेसनको फिल्डमा आजकल पाउँदैनौँ वेन यु पास आउट फ्रम अ ग्रेजुएट एक्चुअली वी डोन्ट हेभ अ अपरेसनल नलेज हाउ टु अपरेट अ नेटवर्क इन रियल इन्भाइरोमेन्ट सो वी ट्राई टु डिजाइन अ कोर्स from our industry experts who has actually operational knowledge and they design the course and they make sure the content is perfectly fit and tailored so that once you receive the training you can just straight go to work and start delivering the results whereas जुन एकाडेमिक हामी युनिभर्सिटीमा पढ्छौँ त्यसले सबै कुराहरू कभरेज गरेर हुन्छ र धेरैजसो कुराहरू चाहिँ कस्तो हुन्छ भने प्र्याक्टिकल नलेजमा चाहिँ अपरेसनल नलेज गरे भन्दा पनि थ्योरिटिकल नलेज भएकोहरूले कोर्सेसहरू डिजाइन गरे हुन्छ जुन चाहिँ प्र्याक्टिकल लाइफमा युज हुँदैन तर हाम्रो चाहिँ जुन ट्रेनिङ मोड्युल्सहरू हामीले गराउँछौँ त्यसमा चाहिँ इभन फ्रेस ग्रेजुएट अर स्टार्टर जस्ट क्यान come and join in a workshop, get trained, and start working and executing and delivering the results. So that's the main motive of npNOG. So having said that, I encourage everyone to network basically when we have a tea break, when we have a lunch break or dinner पनि हुन्छ एकदमै please network each other, please talk to each other, please ask questions, feel free. The reason actually we want to make this event very informal is also like that to make you guys comfortable. Right? So please exchange your ideas and I would like to end with this with my small welcomes note and I just want to share some update of npNOG. How do this work? Okay, so यसको बारेमा मैले भनिसकेँ so I'm just going to skip. So this is also I have a little bit covered. We actually wanted to discuss something that really matters to run the internet efficiently in Nepal. So एउटा त यो कन्फरेन्स भइहाल्यो त्यसको बाहेक मैले वर्कसपको अघि पनि कुरा गरिहाल्यौँ त्यसको बाहेक चाहिँ वी अल्सो अपरेट मेलिङ लिस्ट एन्ड सोसियल मिडिया फोरम त्यसमा पनि हामी डिस्कसन गर्छौँ अहिले त्यति धेरै ट्राफिक छैन तर जसले पनि त्यो मेलिङ लिस्टमा सब्सक्राइब गर्नुभएको छ त्यो फोरममा हुनुहुन्छ प्लिज एक्सचेन्ज एन्ड आइडियाज देयर त्यसको लागि नै हामीले त्यो फोरम चाहिँ बनाएको हौँ सो अर्को कुराको चाहिँ अब आजकल पोलिसिजको गभर्मेन्ट्सको कुराहरू पनि भइरहेको हुन्छ अस्ति नेपाल आइजिएफहरू पनि भयो होइन सो त्यसमा पनि एक्चुली पार्टिसिपेट सो नेपालमा चाहिँ इन्टरनेटको सम्बन्धी गभर्नेन्स र रेगुलेसनमा कस्तो टाइपको पोलिसिजहरू प्रयोग हुन्छ त्यसमा पनि हामी चाहिँ हेल्प गर्न चाहन्छौँ एज अ npNOG राइट अनि एट द सेम टाइम अघि भनिहालेँ कसैले चाहिँ ब्याकग्राउन्डमा कुनै प्रोजेक्ट इनोभेसन छ भने जस्ट टु सो द्याट वर्क होइन अर्को कुरा चाहिँ कम्युनिटी इङ्गेजमेन्ट हो सो npNOG को हिस्ट्री कुरा गर्नुपर्दाखेरि चाहिँ एक्चुली वी स्टार्टेड इन 2016 होइन एन्ड वी फर्म द एडोक कमिटी त्यसमा चाहिँ म छु रामकृष्ण परियार फ्रम सुबिसु अनि क्षितिज नेपाल टेलिकमको हुनुहुन्थ्यो अहिले उहाँ हुनुहुन्न त्यसपछि उत्तम राणा अनि किजुज फ्रम गोल्डिङ सो हामी 5जना मिलेर चाहिँ वी एक्चुली स्टार्टेड npNOG इन 2016 वी अपरेट अ मेलिङ लिस्ट npNOG.org यहाँ छँदैछ एन्ड वी अल्सो हेभ अ वेबसाइट त्यसमा अलिकति केही कन्टेन्टहरू छ जति पनि हामीले चाहिँ कन्फरेन्समा चाहिँ र ट्युटोरियल वर्कसपमा जति पनि हामीले कन्टेन्टहरू छ त्यो सबै कन्टेन्ट हामीले त्यहाँ अपलोड गर्छौँ त्यहाँबाट तपाईँहरूले डाउनलोड पनि गर्न सक्नुहुन्छ Similarly, we also have Facebook, right? And 2016 को मा चाहिँ हामीले भर्सन 0.1 भन्छौँ इनअफिसियली चाहिँ हामीले त्यति बेला चाहिँ स्टार्ट गरेको थियौँ एउटा एनपिआईको एजिएमबाट अर्को लास्टली वी हेभ मेनी सपोर्टर्स हाम्रो इभेन्टमा चाहिँ इन्क्लुडिङ गभर्मेन्ट एनटिए एप्निक एसप्यान धेरै छ आइसक एनरेन पिसिएच सो बिसाइड द्याट यु क्यान सी लट अफ स्पोन्सर लट अफ भेन्डर्स एन्ड ओइएम्स अल्सो सपोर्ट सो यो इभेन्ट गर्नको लागि धेरै पैसा खर्च हुन्छ होइन त्यसको लागि गर्नु पैसाको लागि पनि हामीलाई चाहिँ स्पोन्सरहरूले धेरै ठुलो हेल्प गर्छ सो थ्याङ्क यू भेरी मच थ्याङ्क यू अल द स्पोन्सर्स फर सपोर्टिङ अस सो वी स्टार्टेड npNOG डिसेम्बर 9 होटल हिमालयमा हामीले गऱ्यौँ 2016 मा अनि वी हेभ अलमोस्ट सिमिलर पार्टिसिपेन्ट्स 250+. वी अल्सो डिड वर्कसप इन येलो पोगडा त्यति बेला हामीले भर्खर स्टार्ट भएर दुईवटा गऱ्यौँ एउटा सोहो नेटवर्किङ अर्को चाहिँ अप्टिकल नेटवर्कमा गऱ्यौँ सो दुईटै वर्कसपमा लगभग अराउन्ड 35-40 गरेर वी ट्रेन्ड 75 to 80 पिपल एट द्याट टाइम सो npNOG 2 एक्चुली वी डिड इन होटल मल्ल यो चाहिँ एकदम ठुलो इभेन्ट भएको थियो अलमोस्ट सिमिलर टु दिस साइज एन्ड वी हेड अ पार्टिसिपेन्ट्स अफ 250+. त्यति बेला चाहिँ हामीले अलिकति एम्बिसियस भएर तीनवटा ट्र्याकमा हामीले वर्कसप गऱ्यौँ लगभग 115-120जनाले चाहिँ त्यति बेला ट्रेनिङ लिनुभयो IPv6 V4 राउटिङको गऱ्यौँ नेटवर्क म्यानेजमेन्ट मोनिटरिङको बेलामा गऱ्यौँ र अप्टिकल फाइबरको बेलामा गऱ्यौँ र npNOG 3 सम्म आउँदाखेरि चाहिँ सरी त्यो पिक्चर चाहिँ चेन्ज भएको छ द्याट इज द पिक्चर अफ npNOG 2 सो npNOG 3 मा चाहिँ एक्चुली वी डिड इन चितवन हामी चाहिँ काठमाडौँ बाहिर पनि गर्ने हामीले प्लान गरेका छौँ हरेक वर्षमा दुईचोटि npNOG गर्ने एउटा काठमाडौँमा गर्ने एउटा काठमाडौँ बाहिर गर्ने त्यसैलाई नै कन्टिन्युटी दिनलाई एक्चुली वी डिड इन चितवन एन्ड त्यसमा पनि एटेन्डेन्स राम्रै थियो, 200+ जना पार्टिसिपेन्ट हुनुहुन्थ्यो। त्यहाँ पनि हामीले 3टा वर्कसप गऱ्यौँ, नेटवर्क एसोसिएसन, सिस्टम एडमिनिस्ट्रेसन र फिजिक्स। र अब नेटवर्क 4मा आगो लाग्दाखेरि हामी चाहिँ अलिक एम्बिसियस भयौँ, नट इन कन्फरेन्स बट वर्कसपमा, किनभने एक्चुली कन्फरेन्स भन्दा पनि हाम्रो फोकस चाहिँ वर्कसपमा भएको भएर दिस npNOG इज लिटल बिट डिफ्रेन्ट देन अदर कन्फरेन्सेस द्याट वी हेभ। सो वी डु कन्फरेन्स बट एट द सेम टाइम वी प्रोभाइड इक्वल फोकस टु वर्कसप अल्सो, मोर फोकस टु वर्कसप, नट ओन्ली इक्वल। सो योपालि चाहिँ हामी अलिक एम्बिसियस भएर हामीले 4वटा टपिक चुज गऱ्यौँ, त्यसमा चाहिँ नेटवर्क म्यानेजमेन्ट सिक्युरिटी, बेसिक्स, फाइबर टु द होम, र अर्को चाहिँ वाइफाई। वाइफाई चाहिँ हामीले किन इम्पोर्टेन्ट भयो भन्दाखेरि now the speed of internet is growing really fast. अनि when we deploy a wired network, when we operate 4G, तर at the end of the day घरमा everybody use Wi-Fi, right? So at the end of the day all the service provider is Wi-Fi provider. So the Wi-Fi quality has to be really good. So like Wi-Fi मा नै सबैभन्दा धेरै प्रब्लम आएको भएर चाहिँ actually we feel that internet is performing poor. So that is not applicable, that's not only applicable to host, but it's also applicable to enterprise. So we try to cover this also. So home office मा चाहिँ Wi-Fi network को management र security पनि कसरी manage गर्ने. So finally we are here npNOG T4 team. यसमा चाहिँ अलिकति सानो चेन्ज भएको छ। क्षितिज फ्रम नेपाल टेलिकम उहाँ चाहिँ विदेश जानुभयो, त्यसले उहाँको ठाउँमा चाहिँ हाम्रो कविन्द्र श्रेष्ठ फ्रम पिसिए चाहिँ इन्ट्रोड्युस हुनुभयो र हामीले यो कम्पनी पनि एज अ नट फर प्रफिट अर्गनाइज गर्यौँ। सो द्याट्स अल आई हेभ। थ्याङ्क यू भेरी मच। थ्याङ्क यू अगेन।
थ्याङ्क यू समित। समितजीलाई यस npNOG को बारेमा धेरै भनिदिनु पनि भयो समितजीले, र सर्वप्रथम त समितजीलाई यस npNOG को नेतृत्व गरिदिनु भएकोमा पनि धन्यवाद। अब कार्यक्रमलाई अगाडि बढाउँदै म नेपाल दूरसञ्चार प्राधिकरणका अध्यक्षज्यू श्री दिगम्बर झाज्यूलाई केही शब्द र केही सुझाव व्यक्त गरिदिनु हुन अनुरोध गर्दछु।
Good afternoon, everybody. Chairman of npNOG, MD of NPIX, delegate from APNIC, from Cisco, from Tata Communications, and all the local participants and participants from abroad. First of all, I would like to thank npNOG and NPIX both for organizing such kind of events, especially as a conference, as a hands-on training and workshop. Actually, this sector, the technology of this sector is changing very rapidly, and it is changing every month, you can say, or every day we can change it. So for the professional of Nepal who are involved in this sector, whether it is in government sector or in private sector, it is very supportive, or you can say very useful for upgrading their skill. At least interest is created and they also learn something from that. I would inform this gathering that government of Nepal is very, very serious. Not only doing its job as a normal, but it is very serious. Prime Minister has already given a vision of digital Nepal. And we, as a regulator, we are working to achieve that digital Nepal within very short time. Though some of the legal provisions sometimes delay our endeavor to get it or to be a success. Like if I go for data, you can see that the broadband penetration 4 years back, it was less than 10%, in which the fixed line by our ISPs were 1.7 something, 1.3, 1.5, something like that. Within 4 years, we have come fixed line about 12 or 13%. And if we calculate the mobile broadband, 3G, 4G, LTE, total is more than 50%. So in NTA, Nepal Telecom Authority is always supporting more to the fixed line than to the broadband. Because this is cheaper. There is a concept that fixed line is cheaper and broadband, mobile broadband is a bit expensive or costly. Though there something has happened, we have a target. We have 4 years back, we planned our broadband policy. 3 years back, broadband policy. Then we drafted our ICT policy. Both policies are in place. And it is very ambitious. Within that framework of the policy, main thing for the penetration, increase in penetration is the infrastructure. We have so many barriers for the infrastructure. Sometimes it is right of way, sometimes it is the operators themselves, because the fund we are using is USO fund. It is Rural Telecom Development Fund. And to utilize that fund, we have enough fund. No scarcity of fund is there. But to utilize that fund, we have to go through the operators' licensing. And our licenses, the operators, they are not such you can say dedicated or experts who can do it faster. But still, we have two programs mainly. One thing is a backbone. We call it information highway. That is program is more than 13 billion. We have already allocated to 3 operators, voice operators. Now the second program is to have broadband access in every local body, it is ward or high school or hospitals, and on demand to everybody, with the cost not more than what is existing in the Kathmandu Valley. We have 77 districts, out of we divided it into 18 packages, out of which 15 package has already been allocated. Now for the 3 package, which consist of the plain area, Tarai, we are working on that. So I think this kind of events, we are trying our best to connect every rural. As you hear, every Nepalese and even the abroad, they are knowing that the geographical condition of Nepal. The southern border bordering India is 60 meters from sea level. And if you go straight aerial distance, after 150 kilometers, it is 9,000 meters. So what is the terrain of Nepal? So everywhere it is not possible to go by optical fiber. So in Himalayan region, we are preferring satellite, where it is 15% of the land and only 5% of the population is there. Whereas in Tarai region, bordering India, southern part, it is 17% of the land and 51% of the population live there. So we are preferring optical fiber everywhere there. Now, along with the network or infrastructure, that is not sufficient. So this year, NTA has allocated a separate budget for digital literacy. So in every, we have 753 local body. We call it Gaon Palika. So in every Gaon Palika, we are going to campaign for the digital literacy, so that if the internet is there, broadband connection is there, they can use it. So digital literacy is there. Now we also have a program to develop a skilled manpower. So in this connection, we have some budget. We want to train at least 4 or 5 people from every Gaon Palika, so that if there is some problem with the Wi-Fi or internet connection or with the computer or smartphone, minor problem, they can solve it locally. Otherwise, the network providers like the ISPs had to send their person from here. So a skilled, semi-skilled you can say, semi-skilled person, we are going to invest in that. For digital literacy, we are going to invest in that. Not only that, for local government in the remote and rural area, we are going to establish the information center by providing them 5-6 computers, so that individual can come and use the internet or something like that network. We are providing computers to 500 schools this time as a pilot project, you can say. So in Himalayan region, it will be 10 computers in every school because the number of students is less. In hilly region, it will be 15 or 20. In Tarai region, it will be 24 computers. So computer lab we are. They will produce the digital person, you can say, and they will even the student will train there or guide their parents to use the internet and that and that. So we have so many programs here. Out of 77 districts, we have only 15 districts left in the Tarai region. That also within 2 weeks, tender will be opened. So government of Nepal through NTA is investing a huge money for connecting the people. Now, I must thank the npNOG and that they organize such conference so that the local professionals, experts, engineers, they can get the skill, they can get the knowledge, and that will be used for the purpose of digital Nepal, our Prime Minister's dream for digital Nepal. Besides that, we are aware of the security problem. Our IT Department of Information Technology, which is in the same ministry. Previously, it was in Science and Technology Ministry, and Telecom was here. Even today, even our ministry people or even the NTA board people, they understand telecom as it was 10 years back, only voice. I now convince them this is digital communication. Telecom means digital communication. So we can't distinct it from voice or data or something like that. So we have to work in this line, and I hope that within 2-3 years, our penetration of broadband will be about 80 to 90%. I'm talking about the fixed line. If it is fixed line also, not connected, but we call it Pahuch. There will be the fixed line. If I wish, I can take it within hours. Our program is such. And in that connection, due to the terrain, the network operators will have problem to satisfy them. So their skilled manpower will be very useful. I again thank them, NPIX and npNOG, to organize such kind of workshop for the upliftment of the knowledge and the skill among the professionals, and even the workshop for a hands-on training workshop, which will be very useful to achieve that digital Nepal. I thank for inviting me for such an event, and I wish the success of this workshop and conference. Have a good day. Thank you.
धन्यवाद अध्यक्षज्यू। अध्यक्षज्यूले यसरी नेपाल टेलिकम अथोरिटी र नेपालको कनेक्टिङ पिपल को धेरै एक्टिभिटिजहरू बारेमा यहाँ सबैलाई अवगत गराइदिनु भएकोमा धेरै धेरै धन्यवाद। र प्रधानमन्त्रीज्यूको डिजिटल नेपालको सपनालाई पनि हामी हातमालो गरी npNOG, npIX र जति पनि हाम्रो कम्युनिटी छन्, आइसक नेपाल, एफक्यान, एसआइसिटी, सो सबैजना हातमालो गरिकन सहयोग गर्दै चाहिँ अगाडि बढ्ने कमिटमेन्ट चाहिँ हामी पनि यही स्टेजबाट दिन चाहन्छौँ। Moving on, I would like to request our keynote speaker for today, Mr. Shailesh Gupta, Vice President, Tata Communication, to present his keynote presentation on journey of 64 kbps to 20 tbps. Mr. Shailesh.
Namaste, Mr. Digambar, the chief guest, Mr. Samit, Rupesh, Rajesh ji, Mohit, and organizing committee members of npNOG 4, and all the delegates. I'm Shailesh Gupta, as introduced by Rupesh. I'm Vice President and heading Global Service Operations for Tata Communications. And I'll share with you that our journey from 64K to 20T. And I'm really thrilled to see that when the vision of digital Nepal and the kind of initiatives being taken. And thanks, Samit, for the kind of that when the initiatives you are taking that when creating the skills to manage, that when these providers. We are struggling in India as well. And recently we started our technical university. We hire our management trainees and GET, and we invest almost a year to 15 months just to train to bring to that level. So that's very good initiative taken by that npNOG. And I'll request Rajesh ji also to maybe that one similar kind of initiatives we could take in India as well. So I'd like to that one cover over there. Who are we? That one I'll not spend much time. How the tier 1 backbone looks like that, and different from that one a national provider. What are the tools and systems? Because once you grow, that one beyond, that one beyond a country, definitely, that one you need a lot of tools, systems to work upon. Otherwise, it becomes very, very difficult. That one to manage those networking pieces. I will touch upon that one IPv6 implementations in Tatacom. That one, and what are the current challenges we are facing over here. And few, that one case studies yesterday, Samit told me to include, that one couple of DDoS attacks, that one we have experienced, that one last year. And how we mitigated, that one those, that would be useful, that one for Nepal operators as well. And we have got various, subsea cables over there. We are owner of major, that one subsea cables worldwide. And we are partner in consortium also, that one on various cables. I will touch upon that, how the diversity is being made between Atlantic and that one the Pacific side. And whenever any catastrophic happen, that one simultaneously 2 or 3 cables are also cut, there. Still we are able to manage, that one, and we are able to support our customers, both enterprise segment as well as wholesale ISPs. And certain challenges we are facing over there, like access. Just now I heard, that when the terrain situation in that one Nepal is not, that one good, that everywhere you provide fiber or copper or maybe that one the broadband services. So there are various modes. In India also, similarly, we are facing other kind of issues. And we have come up, that one with some of the options over there. We have conducted POC with enterprise customers. Of course, that one not for very high bandwidth, but enterprise customers, especially MPLS kind of applications. So we'll touch base that. And maybe whatever the queries are there, that one I can answer to. So who are we? That one most of you might be aware. That one we are a part of Tata Group companies, and This company was earlier, it was a PSU, the government of India, named Vide Sanchar Nigam, which has been taken over by Tata in 2002. And before that, it was a pure government of India company, Overseas Communication Services, OCS, before 86. And prior to that, it was a private company, that one, Indian Telegraph Radio. So this Tata Communications also has completed more than 150 years. And Tata Group, this year we are celebrating 150 years completion of Tata Group. So these are the various sister functions. Thank you. We have got the MPLS POP. You can see spread across, that one from one corner of the globe to another corner. These are our MPLS POPs. On the top of that one, we have got partner POPs. You could see that one primarily, that one the region in Africa regions, and here that one we are having partner POPs, where we are not having that one very good connectivity, so we are working with our partners. We have got Ethernet POPs. It's not only internet. that when the customers like, that when the wholesale customers or ISPs, they buy Ethernet traffic for Ethernet pipes, thick pipes from us. that one maybe to the tune of 10 gig or multiple 10 gigs. So they are being served through Ethernet POPs. We have got partners Ethernet POPs also over here. So it's the mix and match of overall MPLS, IP, Ethernet, own POPs, partner POPs. And these are the typical capacities what we are having. You could see that one the North America, transatlantic, Europe, trans-Pacific. that one these are the capacities. And IP capacity, as on today, we are having 20 terabits per second. So that was the theme over there. We started that one with 64K on the day of our Independence Day, 15th August 1995. So almost 23 years, we have grown from 64K. That was point of time. Single link was there through MCI, and now we have reached to 20 terabit. These are some of the capabilities. If you could see that. Inbuilt securities, that one we are providing. Point of presence already there. Consent, we are having that one the content peering with major tier 1 providers. Capacity, IP capacity 20 terabit, and these are the services we are providing. It is not limited to only that one. The only thing that we are not providing to services to residential broadband directly. Our sister concern is their Tata Tele services. Through them we are providing. So we are concentrating primarily on that one: enterprise, ISPs, content providers, OTTs, and cloud service providers. Then it comes over there how our POPs looks like that. You could see that when these are the 3 tier 1 POPs are there. 9 tier 1 POPs are there. All the tier 1 cities of Mumbai, Delhi, Kolkata, Hyderabad, and all that. Then we have got tier 2 POPs over there. And these are the tier 3 POPs. That is the India MPLS network. So we have got 115 POPs over there across India. And we are using, in core, we are using Nokia 7750 SR12. That is in the core. And edge, we are having the Nokia 7750. PMS, we are using Cacti and FMS Monolith. And Snow, recently we have migrated from Remedy to ServiceNow. That is our ticketing system. And this entire journey, we have started our automation journey. That one we call it Optimus, wherein we are changing everything. That one is starting from opportunity level to billing level. Everything is being changed because those systems are almost 15, 16 years old. And they are very closely integrated each other, whether it's OSS, BSS, PMS, FMS, IMS, and all that, those things. So we have started our Optimus journey. That is almost 18 months journey. Around 9 to 10 months we have completed. So as and today we are at 85 to 90% of the proactive level. When I say the proactive level, that means we are working on a theme. I know first. Whenever there is a problem at the customer side, before customer is reaching to us, we know first. That one we call back to the customer. So 85 level percent of that one proactivity is there. Now our intent is that to move towards the predictive and beyond that. So with the help of Optimus journey, we will be able to complete that as well. This is the 6453. That one the network. You could see tier 1, tier 2, tier 3. Similar to that one the previous one. And you could see that one this is the international network 6453. We acquired a company called Teleglobe roughly in 2006-07. That was a second largest company in the world was there, and they are having AS6453, and then they are using dual stack. This is primarily, that one IP transit network. It is enabled MPLS, but majority of the providers are wholesale, and they are buying IP transit capacities. And these are also based on that one, the Alcatel-Lucent, which has now become the Nokia. ILL network architecture, if you could see, that one we are having core. So we are having two different network. One is MPLS based on Nokia, and the second is ILL or IP transit. We are having Juniper, that one MX96480 boxes are there. In the aggregation, we are having Cisco 7600. Earlier, this network was Cisco powered, so we had that one Cisco GSRs over in the core and 7600 boxes in that one the aggregation. And distribution, we are having switches Juniper EX4200 and 4300. So as and today, we are having on that one MPLS network separate and IP network separate. This is the GVPN network, if you could see. This is again that one core, Nokia, SRC7. Aggregation is that one 7750, SRC12, boxes are there. And distribution, we are having Juniper EX4200 and Huawei switches. And of late, we have moved from SDH network at the TDM level from SDH network to MPLS TP. So we are using Sienna and Huawei in that, so that we can directly provide that Ethernet connectivity to the individuals. And it's a lot of benefit. That one we need not to deploy it. As and today in the TDM SDH box, one customer, one MUX is being deployed. In that case, that one we are creating our POP near to the customers or within the building itself, wherein we could deploy that one those boxes, MPLS TP boxes, and multiple customers within the same building or within the periphery could be connected. So initially we have deployed that one Mumbai, Delhi, Calcutta, Chennai, and Bangalore, 4-5 cities on a trial basis. Now we will replicate it to other cities in India and abroad. International cable diversity, if you see, that one India is connected to one side is Atlantic and Pacific. So as and today, that one our this 20 terabit of capacity, around 60% is there, and that one the Atlantic side, and 40% that one we are having that one the Pacific side. And we have got our own cable, Tata Indicom cable TIC, which connects Chennai to Singapore, and Singapore to further that one Japan to US. We have got our own cable, that one called TGN. TGN Tatacom Global Network cable is there, both eastern side and western side. So this is the typical diagram. You might be showing, that one the lot of fiber cuts, that one on the ground for your broadband connectivity and all that. But if you could see, that one scenario in that subsea cable, it is not much, that one different. That one you could see. These are the cuts are always happening over there. That one the snapshot. This is India connected to APAC through these cables over there. We have got tip cable. Sorry. Thank you. So if you could see, that one Pacific side, we are having multiple cables, TIC, CEV4, CEV3, I2I cable. I2I cable not owned by us, it's the Airtel cable, but we have got, that one swiping, that one agreement between Airtel and us. And similarly, that one, if you could see, that one Atlantic side, Marseille, that one we are having TGNEA, that's Tata Indicom cable, IMV cable we are having, CEV4, CEV3, and EIG cables. And further connectivities are there, FT9, FT10, CT2, connected to US. This is the typical diagram, and you could see in a ring, that whenever some cuts are here, we are moving most of the traffic from here or vice versa. And last year, that when the month of December, there was a major cut. 3 cables simultaneously went down over there, 2 from this side and 1 from this side. Still, we have been able to perform. So that level of diversity, we are managing, that one at the both Pacific side as well as Atlantic side. Lot of rates are there. You could see, that one, this is the typical uptime of a cable system. You could see 85% CEV3 Atlantic has been there. You could see, and while we are providing 4.959 kind of, that one the uptime to the customers. This is only possible when you do having, that one these many, that one cables, diversify, that one Pacific side as well as Atlantic side. Some of the cables you could see, that one 29%, TGNIA. The typical issue is there whenever subsea cables are working, it's well and good. Whenever any cut is there, it takes minimum 45 to 60 days. That one, depending on that one, the approval. while we are crying for that one ROW permission. But in that cable permissions, I mean, that one is really very, very tough. I mean, that one, those country-specific defense system, I mean, that one we need to follow it up. And the ships for repair, I mean, that one, there's also, I mean, that one, it's fixed. It is not like that anyone XYZ, you can call them in from the market and go. From the security aspects, lot of, I mean, that one, the difficulties are there. So some of the cables you could see, I mean, that one 82%, 29%, but still, I mean, that one we are able to manage. So what we are doing, we have done a mathematical modeling over there for cable system. If you could see, I mean, that when in 2012, these are the uptimes have been there. So from 2012 to 17, I mean, that when we have taken uptime of each and every cable over there, and we have done some projection for 2017. So here also you could see, I mean, that one if the best cases, known cases are there, and these are the bus scenario, I mean, that one are there. So within that, we need to manage, I mean, that one the traffic, both eastern side and western side. So based on this one, the mathematical modeling, we have again rearranged our capacities over there. From Mumbai, if you could see, just now I told them that one around 20 terabit we are having for our international capacity, but India exit is roughly 900. From traffic which is going out of India or coming to India, that is roughly, I mean, that one 900 gig is there. So we have almost, I mean, that one 50% we have divided through Chennai, Singapore. These are the cables are there, CE4. BBG, again, I mean, that one we have bought the capacity. It's not our own cable. And Tiki is our own cable, 400 gig is there. BBG, again, we have taken, I mean, capacity between Chennai to Singapore. And Mumbai to, again, I mean, that one Marseille, we have taken EA, SME, SME4, SME3. And SME5 also, we have taken, I mean, that 100 gig. Also, although we are not a part, consortium member of SME5, but we have taken 500 gig, 100 gig capacity for this one, Marseille to Singapore. Tools and systems, as I just touched upon, I mean, that one, once you grow the network, I mean, that one beyond tier 2 to, I mean, that one, the tier 1 truly, the tools and systems, they are playing a real role over there. So you could see, I mean, that one, these are the systems. I will start from that one, the Kramer. Kramer is our inventory system. So our automation journey, we have started just when Tata took over in 2002, roughly, I mean, that one, 2002-3, we started. First, we thought, I mean, that one, until unless we know what are our inventory. Kramer is, I mean, that one IMS, is inventory management system. How many routers you are having, how many switches you are having, how many pipes you are having, their inventory. So we have automated everything in the Kramer. From 2002 to, I mean, that one, as in today, I mean, that one we have moved, I mean, that one, still we are on Kramer. Kramer 10 we are using. So entire inventory is, whether it's IP network, whether it's Ethernet network, whether it's transport network, everything is, I mean, that one modeled in Kramer, up to customer CPE. And when the customer CPE is managed by Tata, we model, I mean, that also. So that CPE level, I mean, that one modeling has been done, both logical level as well as physical level. Then we have got, I mean, that one Metasolve, I mean, that one, the order management tool we are using for ordering systems over there. All the orders are coming over there. And prior to that, SFTC is there, you might be aware, Salesforce.com, that is our BSS system is there. All the opportunities are coming from there. Then ordering starts from here. And WPS is the tool IBM, which takes care of, I mean, that one update from all the services, stat update. And 4 years back, we have implemented a system called ACE, Auto Config Engine. So as and today in Tata's network, nobody is having the access to routers. Nobody is typing config T and all that. Those things are, I mean, that one have been, all the access have been taken off. So this is fully automated. We are delivering almost 7,000 links per month. That is only for and wholesale. And every order is passing through ACE system. Whether it's a transport order, if you could see transport network is there, or IP network, IP boxes are there, whether it's a Cisco gear or Juniper gear or Nokia gear, they are being provisioned through ACE system. So ACE system, it takes input from Metasolve, customer related information. It takes from Kramer all the inventory related information, and it pushes, I mean, that up to any level. So whatever networking elements are there, configs are being pushed. Not only config pushing, beyond that one, it is testing is being also done. Suppose something, I mean, that one we have given the SLA to the customer, 120 millisecond latency from point A to point B. It will throw, I mean, that one the test, and test results are being captured. If those test results are beyond, I mean, that one expectation, again, there is exception desk over here in ACE. It comes over there, and which we are checking what is the issue over there. Geneva is that one, the billing system we are using. Snow is the trouble ticket system, I mean, that one which recently we migrated from Remedy. we had remedy and various instances were there. I will touch base, I mean, that one we had 3 instances of remedy, one for India, one for international, and one for other, I mean, that one companies what we have acquired. So how we have, I mean, that one the done, integration of those tools, that will touch base going forward. From customer side, that was from that one delivery and network side. From customer perspective, we have given customer portal, which is integrated with ServiceNow, I mean that trouble ticket system. And we have got the CIDR engine, cross-domain integrated diagnosis. We have got Unite, I mean, again, we have got different networks over here. We have got the voice network. For voice network, we are having Unite, RTDS, and Telecami. These are the tools we are using. For Spotlight is the tool for transport gear. So whatever the transport gear, we are having multiple transport gears are there. NEC, Alcatel, then Tejas, Huawei, Sienna, multiple transport gears are there. So we are having PMS tool called Spotlight. Then we have got wireless one. I mean, that one, this is for wireless. We have got around 40,000 of the customers, high-end enterprise customers, they are riding on wireless. In India also, you know, it's a vast country, everywhere providing in tier 3, tier 4 towns, where small banks are coming up. Earlier, there was a concept of tier 1, tier 2, tier 3. Now the concept of tier 4 and tier 5 is also coming up in small villages and all that. All the branches, bank branches are being opened, and they want the MPLS connectivity or internet connectivity from day one. It will not be possible to operate, and Government of India, Reserve RBI has already, I mean, that when they issued the guidelines, every transaction has to be done online. There is no manual work over there. All the banks have to be connected on that one digital payment system over there. So we have got RF network and the PMS, it is wireless one. We are using PMS. Monolith is, I mean, that one PMS for SD-WAN, I mean, that one the last year we have deployed. So Versa code, Versa is, I mean, that one the box we are using. And now we are moving to Viptela as well for SD-WAN. Save one is, I mean, that one for PMS for SD-WAN Prime. That's another one. This is Cisco-based SD-WAN we are having. And we have got around, I mean, that one 200 live customers across the globe, and around 3,000 links customers are using on SD-WAN, both flavors, Prime and Select. Then we are having Concord, I mean, that one the tool which we are giving to the customer space. And Regi is the tool which we got from Teleglobe as in after the acquisition. So everything is being, I mean, that one consolidated into one or two PMS FMS tool, the way we have done earlier for delivery lifecycle. This is the India core network. This is being monitored 24/7. If you could see, I mean, that when these are the multiple pipes are there, and these are the nodes. So every node, I mean, wise, we are critical parameters we monitor, CPU utilization, memory utilization, and all that. For the link, we monitor, I mean, that when the latency, jitter, utilization, and all this stuff. And based on that, when the trigger is going, not to only manual, the trigger is going to ServiceNow, and network TT is being opened automatically, and that TT is going to our NOC, and NOC is working on proactively on that TT. So there is a system called SIA, Service Impact Analysis. Once the network TT is being opened, whatever the child TTs are there, our customers are associated on that network, it is getting, I mean, that one attached with that network TT. And once the network TT is closed, all the child TTs are automatically getting closed, and customers are being proactively informed that yes, we know, I mean, that when, hey, Mr. Customer, you are having a problem. We know, I mean, that when we are working from our side, and this is the ETR, maybe 2 hours, 3 hours. And then the customer also is happy, I mean, that when at least my provider is aware what problem I am having, and they have provided, I mean, that when the ETR, when the links are going to be reached to. Similarly, some other weather maps are there. You could see, I mean, that one Africa network, and this is our GVPN network. So every network is being, I mean, that one monitored, and some threshold have been put over there. As for the link utilization, latency, and packet drop is there. If these KPIs are crossing those threshold, automatic alerts are coming, and they are getting converted into trouble ticket. Maybe this slide will be useful. I mean, that one I added. Some of that one, the development we have done. This is Vide is the tool. I mean, that one most of you might be knowing. I mean, that when the customer has taken primary and secondary both links over there. So whenever any SEV1 issues are there, hard cut, I mean, that when traffic is switching primary to secondary and vice versa over there. But whenever, I mean, any SEV2 kind of issues are there, that is packet drop, jitter, latency. So we have developed a tool, I mean, that when using EEM of Cisco, that is the EM Cisco we have used. We have developed a tool, and as on today, this, I mean, that when the Vide script we have deployed to almost, I mean, that one 2,000 links, and we see, I mean, that when there is a improvement, I mean, that one in number of TTs. So before customer is coming up, I mean, that one to know, I mean, that when their applications is getting impacted, we are switching over, I mean, the traffic from primary to secondary. And our NOG gets an alert at same point of time. In the background, we keep on working and restore, I mean, that one, the links. Second, proactive monitoring, as I told, for segmentation. Out of 5,000 customers, roughly, we are having entire globe. Out of that, top 300 we have dedicated where from our 80% revenue is coming. So definitely there is a segmented approach. I mean, that one, all the customers need not to be treated equally, but definitely, I mean, that one, the customers, those who are giving on that one most revenue. So 300 customers, their proactive TTs are being opened. Whether they have taken managed services or not, irrespective of that, we are opening a proactive TT and informing to this set of customers. Third is HPU utilization, that is high bandwidth utilization. Majority of the CVAT2 cases you could see, when the bandwidth is utilized beyond the subscribed, I mean, that one the bandwidth. So it will take care of that high bandwidth utilization, and it will generate a trouble ticket, and it gives the customer. Yeah. Email integration, Eagle Eye, I mean, that one is very good tool. I mean, that one, it's a power sensing unit. Whenever any power fail is there at the customer side, this box is there. It will send an SMS to our trouble ticket, and TT is being generated. So around 30% of the cases, trouble ticket is being, I mean, that one avoided by this one system. Probably this will be useful for, I mean, that one Nepal also, where power condition, I mean, that one the countries are the areas where power condition is not very good. I will quickly, I mean, that one I've been told, I mean, that one only 5-6 minutes are there. So we have got, I mean, that one IPv6, I mean, that one we have deployed these two, I mean, that one models we have used, dual stack IPv6 we have used, and our IPv6 over MPLS we have used out of these 4 techniques. And this is, I mean, that one V6, V4 tunneling for 6453 family IP transit. And this is for MPLS network. We have used 6PE, I mean, that, and up to CPE we are providing. Unfortunately, I mean, that when we are not having much traffic on V6, hardly 10%, I mean, that when the traffic is there on that V6. DDoS, I mean, that one I'll quickly, I mean, cover. There are 2 case studies. There is last year a lot of, I mean, that when the threat was there in Indian PSU banks, I mean, that when ransomware, where, I mean, the people, they told, I mean, that they are going to attack, they informed in advance. And one of the PSU bank in South India, it got attacked. What has happened, I mean, that when this got attacked, the backbone connecting to this PE got impacted, and this PE became unreachable. As a result, other customers connected to this PE also got impacted. So, this is the second case where, I mean, the customer is connected to Mumbai and Chennai, where, I mean, the attack was there, and the CR2, I mean, that one our core router, I mean, that one it got inaccessible. So what we did, I mean, that one we have deployed in our both the network 6453 and 4755. 13, I mean, that one the Arbor boxes, I mean, that one TMS we have applied. This is the normal scenario when the traffic goes over here. And the customer is buying, I mean, that one the detect and mitigate, I mean, that one we are providing, I mean, that one /32 address routing is going from here to PE, and the traffic passage, I mean, that one through one clean pipe is being given to the customer. So this we have applied, and these are the certain, I mean, that one maybe, I mean, that one I'll take a couple of more minutes if you don't mind. I mean, that one to cover what are the challenges we face. In 2007, we have acquired a company, Teleglobe. So these are the challenges we have faced. Like, I mean, the 2 different networks were there. So one was, I mean, that one the 4755, 6453. We have taken a call to maintain both the AS numbers separately for different kind of customers. This is primarily enterprise customers, and this was for wholesale customers. We are still maintaining that. And operational integration, their operation was there fully in Montreal. So we integrated TSC, SOC, NOC, tag, everything. So we brought everything from there to Pune, our center. We sent around 100 people over there who have been there for almost 3 months. First, they learned, I mean, that one, all the activities. Then they came to Pune. Then the parallel operations were run, I mean, that one for almost 3 months. And then we have taken over. So as and today, of course, we are operating globally, I mean, that one from three places, Pune, Mumbai, Maharashtra, India. Then we are having Cressex in London, and Montreal in US, so Canada. So all the 3, I mean, the places we are operating follow the Sun model 24/7 basis. Then, I mean, that one other NMS tools integration I have just touched upon. Regulatory issues, still we are struggling. I mean, that one they follow US NSA, and that one India TRI and all that. So we are managing, I mean, that one both. This is, I mean, that one the last piece of this one, I mean, the presentation. That is, we are having almost 50% of that one the last mile through our own on-net wireline. That is primarily, I mean, that one the fiber and copper also. So this is, earlier it was SDH network, NEC, Sienna, and Tejas. Now we moved to MPLS TP. So we are, that when the top 10 cities we have covered, Huawei and Sienna. 30% number, that one we are having RF network, we are having around 40,000 the links are there. And we are having 16D 3.3 gigahertz license band WiMAX, which is still there. And point-to-point and point-to-multipoint UBR we are using for 30% links are there, over there. This is from E1 to 10 meg. This is the new one, and 20% from off-net partners. That we buy also and we sell also to them, like Airtel, Arcom, that one other players are there. So what has happened, that one there is a consolidation happening in India. You might have heard a lot of companies have been closed down, like Aircel, Arcom, and all that. So we face a lot of issues. So what we are doing, that one over here, this is the typical scenario. You see, a lot of infrastructure work is going. This is the typical city of Bangalore. You see red color everywhere. That when the fiber is getting disturbed by these activities, infra activities. So this was, the challenge. So we have found one box. That one. This is based on that 4G and LTE. It supports 8 SIM over there, and it aggregates the traffic. It is not in isolation. Suppose, that when you have put, that one 4 or 8 SIMs over there, and we have seen practically that we are able to get up to 8 meg of that bandwidth. Only challenge is there is no QoS in the BTS. So we are working with those, that one providers, how to, that one they can, whether they can, reserve some bandwidth for enterprise grade. So this is the typical, that one the box is here, sitting, that one just next to router of the customer. Internet cloud, it is coming to a centralized system, balance 2500 is that, making a tunnel. And this is the MPLS, that one the node. From there, customers can go to any other part. This is the typical, you would be able to see how much RSI and CNR values are there, sitting in the NOC itself. Per SIM, you could see, that one in SIM 1, SIM 2, SIM 3, SIM 4, what are their values are there. And based on that one, it selects, that one the path. You could see almost, this in the test, live environment, 6.979 Mbps of traffic we are getting over there. So that's all from my side. If any queries, if you can reach out to me. My email ID is shailesh.gupta@tatacommunications.com, and this is my mobile number. And prior to working with Tata Communications, I worked with Government of India in multiple projects. So I'm well aware what kind of, that one the difficulties are being faced, that one by operators. Thank you.
Thank you, Shailesh-ji. Very, very informative presentation. I'm sure a lot of big ISPs, network operators have learned from your presentation and have taken note of all the things that Tata has learned over the year. Going from 64 kbps to 20 terabits per second is quite significant jump. I still remember my initial days in Nepal Telecom back in 1998, and I still got that piece of quotation from Teleglobe. I think the 2 Mbps quotation I got from Teleglobe was for $36,000. So that was the story back then. I wish I could share that. I forgot to bring it, but I wish I could share that. Before we end, I would like to request our Honorable Chairman to distribute a token of appreciation to some of the presenters. Sorry, if you can come over. Samitji, if you can also accompany. First, I would like to request Mr. Pubud Jayasinghe to come up front and accept the token of appreciation from our Honorable Chairman. Thank you, Pubud. Next, I would like to request Mr. Ramkrishna Pariyar for presenting on manners. Next, I would like to request Mr. Sachin Thakuri for presenting on the threats on Nepalese cybersecurity. Yes. Mr. Sachin? I believe he's outside. Next, I would like to request Mr. Mohit Saxena from Cisco System to accept the token of appreciation. Next, I would like to request Mr. Shailesh Gupta to come up on the dais and accept the token of appreciation from Chairman. Yeah. Thank you, Shailesh. So next, I would like to request Mr. Samit Jana, Chairman of npNOG, to present token of appreciation to Chairman of NTA. Thank you, sir. Thank you, sir. With this, we come to an end of the opening ceremony. I would like to request everyone to proceed for a lunch outside, and if possible, we would like to reconvene by 2 o'clock, if not by 2:15. So let's see if you can manage to be here by 2 o'clock. That'll be great. Otherwise, 2:15. Let's start our next session. Thank you, everyone.